First of all, I sincerely thank the International Academical Review Committee for its support and encouragement to my research work. Thank you also for my best research work. Next, I make a brief presentation of a typical research case. This research title is Polyurethane Elastomer Layered Nanocomposite Materials for Sports Ground and the Preparation Method thereof. Based on this research topic, mainly from 4 parts to discuss. That's the introduction of this study, experimental preparation method, experimental preparation analysis, and conclusion. The introduction part merely stated 5 aspects. Polyurethane elastomer layered nanocomposite, significance, purpose, and question of this study, properties of polyurethane and layered structure, properties of polymer nanocomposite, algorithmical models of nanocomposite. 1.1 Polyurethane elastomer layered nanocomposite. Many scholars have conducted related research based on the polyurethane elastomer layered nanocomposite and its preparation method. The author conducted research on the modification of polyurethane, but lacked corresponding research on various aspects of its properties, such as mechanical properties. The authors conducted related research on elastomer composite materials, but did not explain the experimental characterization. On the other hand, the authors has conducted a mechanical study on the properties of elastomer composite materials, but has not prospects for the application of this elastomer material. 1.2 Significance, purpose, and question of this study. Polyurethane as a rubber material can relieve the load on the ground and provide seismic design for the venue, which is of great significance for sports venues. In order to improve the seismical resistance and abrasion resistance of materials for sports fields and reduce accidents in sports. The article has carried out research on the polyurethane elastomer layered nanocomposite for sports field and their preparation. Based on the above research purpose, how to improve the dispersion of nanoparticles and enhance the compatibility between nanoparticles and polymers is an urgent problem to be solved. Report 3. Properties of polyurethane and layered structure. Polyurethane has excellent comprehensive properties such as high stress, strong load bearing capacity, good wear resistance. Polyurethane have a good vibration and noise reduction effect. Polyurethane materials can attenuate 10% to 20% of vibration energy at room temperature. 1.4 Properties of polymer nanocomposites. Mechanical properties, the mechanical properties of polymer phonogenic nanocomposite are merely reflected in the enhancement of the material strength, toughness, and age resistance. Thermal performance with the addition of nanoparticles, polymerization of the thermal stability of the materials based nanocomposite is significantly improved. Hydrophilic and hydrophobic properties. Study has shown that adding nanocalcium carbonate to the polymer PP can increase the hydrophilicity of the polymer. Report 5. Algorithmic models of nanocomposite. Based on the above properties, there are also the following models for a nanocomposite: Nielsen model, BLN model, cluster model, Validivine model. Part 2. Preparation experiment. The experimental preparation method of merely was conducted 3 parts, namely experimental materials and equipment. Experimental preparation method, characterization, and test method. 2.1 Experimental equipment and materials. The experimental equipment and materials shown in Table 2 and 3. Table 2, the experimental equipment is shown equipment name and instrument model. Table 3 are shown in some experimental materials. That's experimental materials is name, chemical formula, and specification. 2.2 Experimental preparation method. In the method parts, this article introduces a smaller amount of polyurethane and polyurethane elastomer formed after polyurethane modification, and introduces the preparation method and the process of the layered compounds and nanocomposite. 2.3 Characterization and test method. The infrared spectroscopy instrument for component analysis of pure polyurethane was used. The elemental analysis instrument was used to analyze the mass fraction of the hard segment in the polyurethane matrix. The particle surface morphology analysis instrument was used to observe the particle morphology of the composite material. Emission scanning electron microscopy was used to observe the cross-sectional profile of composite material. The viscoelasticity test instrument was tested the strength and strain of nanocomposite. Part 3. Experimental preparation analysis. Experimental analysis include hard segment quality score, mechanical performance analysis, thermal decomposition behavior analysis, dynamical mechanical performance analysis. 3.1 Hard segment quality score. Table 5 is the test result table of the mesh score of the polyurethane head segment. It can be seen that the trend of the hard segment mesh score in the polyurethane sample made is in line with the experimental design trend. And the accurate composition of the sample is basically consistent with the design value. 3.2 Mechanical performance analysis. Figure 3 shows the tensile stress strain covers of water, polyurethane, and graphene oxide composites. It can be seen that as the graphene oxide content increases, the tensile strength increases significantly, while the elongation at break becomes smaller and smaller. 3.3 Thermal decomposition behavior analysis. The heat release rate, dynamical covers of pure WPU materials, and graphene oxide composite material are shown in Figure 4. This shows that graphene oxide has a good flame retardant effect on the polyurethane matrix, and the more contact, the better the flame retardant effect. 3.4 Dynamical mechanical performance analysis. Figure 7 shows that different scanning calorimeter of different SHBP modified polyurethane elastomers. It can be seen that all polyurethane elastomers have a glass transition of around 40 Celsius. It also be seen that the glass transition temperature moves to a low temperature with the increase of SHBP content. Part 4 Conclusion. In this study, we can find the hard segment in polyurethane backbone has a larger volume and rigidity, while its softer segment has a good flexibility. Meanwhile, due to the good mixing of polyurethane elastomers and nanomagnets, polyurethane elastomers, nanocomposite materials have good dimensional stability and barrier properties. With the increase of graphene oxide content, the tensile stress increases significantly, and the elongation at break becomes smaller and smaller. It can be seen from the experimental results that the preparation of the polyurethane elastomer layered nanocomposite materials design in this paper has a good application effect on sports venues. The end of my presentation. Please review. I look forward to your valuable comments for me. Thank you.